Hello everyone, welcome to Technologies Discussion Channel. Today, I'd like to continue the discussion on wireless connectivity. Okay, so earlier on, I have done the part 2, part 3, and this will be the part 4 series discussion. Okay, I'm going to discuss on the various way to classify wireless connectivity. Okay, on the second part, I actually discussed how can we actually segment the wireless connectivity against the range and also the transmission power, and then data rate and also bandwidth. Okay, you can see that the range and transmit power, they are related. Okay, the bigger the transmit power, the longer the range. Same as data rate. The larger the data rate, then you need a larger bandwidth to carry the data. On my part 3 series discussion, I have also discussed on the security aspect on the wireless technology. Okay, from almost no secure all the way to the mil spec of secure. Next, I also mentioned about the latency, okay, on the delay, okay, on the connectivity. Some so-called IoT application, okay, allow us to have a large latency, while some application like autonomous vehicle don't allow us to have a large latency. This video, okay, I will continue to discuss on the various classification of wireless technology. This video, okay, I will concentrate on power consumption. Okay, so this power consumption is actually highly related to transmit power. The larger the transmit power, that means that the larger the power consumption that you actually need to use. Okay, so therefore you can see that these two terms, they are quite similar. Okay, and then the another parameters that I'm going to discuss on the classification of wireless technology will be the number of connected device. Now the number of device actually explode, okay, which means that the number of device used to be in terms of only 100K, maybe 200K. Now it's even go into the millions of so-called end device, and probably, okay, at certain time it will go to billions of end device. So basically, it is also very important to classify wireless connectivity based on the possible of the number of device that can be hooked on to the gateway, for example. Okay, so this will be the part 4 series discussion on wireless technology. Okay, so guys, if you're keen to know more about wireless connectivity, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on the different types of wireless connectivity. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, you are always welcome to ask me through the comment. Okay, before I continue, guys, I'd like to urge you guys to spend a few seconds to press the like button. This is very important to me. Help me, okay, by press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Okay, for those who are so-called can contribute to the learning committee, okay, so you can always leave your comment, okay, under the connectivity portion so that you can share your knowledge in this committee. Okay, once again, thank you so much for strong support. Okay, so let's quickly understand, okay, in terms of power consumption, okay, how we can actually classify the different types of wireless connectivity. Okay, wireless connectivity technologies can also be classified based on their power consumption, okay, which directly impact the device battery life, energy efficiency, and sustainability. Okay, power consumption is particularly important for battery operated device such as IoT sensor, wearable and mobile device, as well as for large-scale deployment that require minimum maintenance. Basically, in short, okay, for example, you are going to deploy some of the sensor and you probably will not need to change the battery again. So therefore, this power consumption is very important. Some of the IoT deployment, for example, deploy in a very difficult to reach or maybe some hazard place. So therefore, okay, we don't want to change the battery as long as possible. So therefore, power consumption become a very important parameters when we actually decide what kind of wireless connectivity that we are going to deploy in this region, for example. Okay, so under this power consumption, we have 4 category: ultra low power, moderate power, and also high power consumption. So basically, let's take a closer look. Okay, let's start off at the ultra low power wireless technology first. Okay, when we mention about ultra low power, which means that the power consumption is in term of microwatt or maybe maximum up to milliwatt. Okay, so why we want to do this is basically we want to design mainly to prolong the battery life as long as possible. So the minimum for this ultra low power, okay, basically the battery life is expected to last for years rather than months. So keep this in mind. For ultra low power, we want our battery life to be able to support in terms of years. Okay, so basically I think that 3 years is a very reasonable timeline, okay, for this ultra low power wireless technology category. Okay, because of long battery life, we can't transmit lot of data. Okay, when we actually transmit a large data rate, then we require a so-called a stronger power to transmit the data. Hence, because of this, we actually constrain the data rate to be low, and also we don't frequent communicate as much as possible, which means that we keep the number of communication to the gateway as minimum as possible. So therefore, in this case here, we have actually infrequent communication so as to achieve to save power. Okay, so basically with this, you can see that this is actually ideal for IoT deployment and maybe some of the sensor network, basically with some constrained energy source, which I have highlighted. So some of the key example for this ultra low power wireless technology will be LoRa. Okay, so basically you can see that LoRa, the power consumption maybe maximum 50 microwatt in standby. When they actually transmit, okay, they only transmit about 100 milliwatt. Okay, so the key application for LoRa, in fact, not limited to these two. They are so long. Okay, but in short, for LoRa actually is a good implementation for agriculture and some form of remote monitoring. So the key feature is basically they have long battery life, up to 10 years, maybe up to 5 years. Okay, so for me, I would say that up to 5 years. For Sigfox, the power consumption, okay, is actually slightly more than LoRa, but in most of the case, Sigfox don't actually consume a lot of power. Okay, most of the time, Sigfox is end device is actually under deep sleep. Okay, so basically they are majority in deep sleep. Okay, so basically for Sigfox, probably up to 100 microwatt in standby. So the key application for Sigfox will be asset tracking and some environment monitoring. Okay, for example, the temperature, humidity, etc. Okay, so the key feature of Sigfox is they have minimum energy use for small data packet. Okay, because Sigfox cannot send a lot of data, so therefore they don't use a lot of energy to transmit the data. So therefore they have this ultra low power. Next will be Bluetooth low energy. Okay, remember for Bluetooth, there is actually classical Bluetooth and Bluetooth low energy. For this case, I like to mention that this is only for Bluetooth low energy. Okay, you can see over here, Bluetooth energy is maybe maximum up to 50 milliwatt during transmission. So the key application, okay, nowadays there are more and more wearables, more and more fitness trackers. So basically, they are under BLE. So the key features is basically they are actually optimized for intermittent communication, which means that you don't require to link the line so-called continuous. As and when you have data, you just send. So basically, they are actually optimized for this kind of application. Okay, next, under low power wireless technology. Okay, so the power slightly increased, okay, up to milliwatts. Okay, so the key feature is basically they are very efficient for moderate data transfer and periodic communication. So basically with this application, you can imagine that from time to time, you need to send a data. Okay, so basically it's a very periodic communication here, and you have some moderate data transfer, not so small, definitely not so big. Okay, so the key idea is they actually balance the power consumption and in terms of the functionality. Some of the example, for example, will be Zigbee. Okay, Zigbee power consumption is around maximum 100 milliwatt. So I guess by now you should know that Zigbee is popular, okay, for home automation and then for some of the industry IoT deployment also. The key feature Zigbee because they actually allowed to have mesh network. Okay, in fact, Zigbee is the pioneer, okay, for mesh network, and they also reduce the individual node power needs. Another example for low power wireless technology will be Wi-Fi high-low. Okay, basically it's a 802.11 AH standard. Okay, the power consumption is slightly higher, okay, which is around 150 milliwatt. So the application is simply for low power IoT, and they have extended range application. So basically for Wi-Fi, they can even extend the range. So basically they call this Wi-Fi high-low. The key feature is basically they support long range and also low power communication. So this is for low power wireless technology. Okay, next okay, will be on the moderate power wireless technology. Okay, the power consumption could be maximum up to 1 watt. So let's come to the key feature. this is actually suitable for continuous data transmission. Early on, those that I mentioned, they are not suitable for continuous data transmission. For this case here, from moderate onward, then this is actually suitable for continuous sending of data and also for some interactive use case here. Okay, so this actually require a higher energy resource as compared to ultra low and low power technology here. So some of the example here, okay, so basically for Bluetooth, classical Bluetooth, for example, our headset, they actually transmit quite a bit substantial of data. So therefore, the power consumption can be quite high. Okay, so this is what I mentioned earlier on, our headset and some of the so-called other device that can be hooked up to our mobile phone, for example, which they need to support a reasonable high data rate. And because of this, we actually need to have a moderate power wireless technology. Okay, so the feature is basically they have higher power as compared to Bluetooth low energy, and they are definitely optimized for audio application. Okay, next example will be the Wi-Fi 802.11bgn, slightly a little bit backdate wireless technology. Okay, so basically, not so long ago, we are still using this kind of standard 802.11n. Okay, but now we move to BE Wi-Fi 6 standard. Okay, so the power consumption, okay, maximum up to 500 milliwatt. Key application, okay, basically at that time, we actually serve the internet using this Wi-Fi standard. So this is for home networking and also internet access. Key feature, okay, they actually support higher power requirement for higher data rate. Okay, but nowadays, internet or Wi-Fi, okay, basically require more power to serve higher data rate. Okay, let's take a look on the last one, okay, which is the high power wireless technology. Okay, so basically this power consumption, typically they are actually greater than 1 watt. Okay, key feature, okay, because as I mentioned earlier on, high power to support high data rate because you need to have a higher bandwidth so they can achieve higher data rate. Okay, so basically this is what you mean, wide bandwidth. Okay, but they require some substantial energy to do these tasks. So they are best suitable for short range. Okay, so basically you cannot increase the range. If not, the power will be even greater. So therefore, this is only suitable for very short range, high throughput application or device that don't have any power issue. Basically, maybe they are hooked up to a AC. Okay, so basically, this is the use case for this high power wireless technology. Some example, okay, for example, currently we are using this Wi-Fi 6 and 6E. Very soon will be Wi-Fi 7. So basically, these are, we know this as 802.11ax standard. Okay, the power consumption, okay, maybe up maximum up to 5 watts. Okay, the key application, you know that they actually have high-speed internet and they are mainly used for gaming and also video streaming. Key feature, okay, we are going to have advanced power saving features, but still they require a lot of energy in order for them to work well. Okay, cellular 4G and also 5G. Okay, so basically this will be at the sub 6. Okay, so basically the power consumption, okay, is slightly higher as compared to Wi-Fi. Okay, so basically, as I mentioned, as for cellular, is basically is a form of mobile broadband and IoT gateway. So the feature is basically we need higher power, okay, so as to maintain wide area connectivity. Okay, because okay, we are using cellular, okay, which is supported by base station, we cannot deploy so many base stations. So therefore, okay, we need to transmit a higher power in order to have a longer range. So therefore, for this case here, okay, the key feature is basically they transmit higher power so as to maintain the wide area connectivity. Okay, last but not least, on the satellite communication, okay, so definitely satellite power consumption is probably the largest, up to 100 watt. Okay, imagine this, we are going to transmit all the way to the space. So therefore, the power that we actually utilize will be quite substantial. Okay, so the key application will be for the remote communication. Okay, for example, some of the rural country, okay, which they are not supported by base station. So the only form of communication will be through the satellite. And also for the defense, okay, most of the time they also will rely on satellite communication to provide a form of communication. So the feature is basically they are extreme high energy requirement for long distance communication here. So basically this will be for the high power wireless technology. Okay, so let's come to the quick data to show it to you. Okay, so under this power consumption, we have ultra low, low power, moderate, and also high power. You can see that the power start to increase. And these are the different wireless connectivity that fall into the different category and also some of the key application and also the feature. Okay, so before I continue, guys, again, I think this is very important to me. Guys, please help this channel by like this video. If you had learned something from this video and if you are new to this channel, really urge you guys to help me by subscribe to this channel and also turn on your notification bell. Once again, thank you so much for strong support. Let's quickly discuss on the last part on the connectivity, okay, which is the number of connected device. Okay, so basically the number of connected device become very important. Imagine, okay, nowadays we have millions, billions of device maybe. Okay, so therefore, the number of device can be hooked up to the gateway become very important. So therefore, we may choose the wireless so-called connectivity based on the number of device that they can actually support. So this is why this number of connected device become very, very important. Okay, so wireless connectivity technology can also be classified based on the number of connected device that they can actually support simultaneously. Okay, this is a critical factor in selecting a technology for application such as IoT, smart home, industry automation, and also public network. Okay, so for the number of connected device, there will be low density, which they don't support a lot of so-called connectivity here. We have medium density, high density, and also the ultra high density of wireless technology. Okay, let's take a look on the low density wireless technology. Okay, so the number of connected device, there are very few, probably fewer than 10 device per access point or hub. So basically, access point can be gateway or hub. Okay, so basically, they can only support up to 10 device here. So the key feature is basically they are actually designed for point to point or small scale network, okay, which means that mainly they are do for point to point, which means that from transmit to receiver, okay, it's not a mesh deployment, mainly for point to point or very small scale of network. The simplicity protocol with minimum resource management. So basically, they make the thing very simple, okay, because you don't have a lot of so-called device connected to the gateway. So therefore, anything on the protocol, they will be simplified. So some of the key example will be the Bluetooth classical. Okay, remember if you had looked at the Bluetooth video, you know that the maximum device they can hook up to the master will be 7 slave and 1 master. So therefore, we can have up to 8 devices in a net. Okay, so application, okay, I guess you already know. Okay, for example, keyboard, mouse, and headphone also. So basically, these can support Bluetooth classical. So the key feature is basically they will be sufficient for personal or small network setup. Okay, because you don't need a lot of device that hook up to your mobile phone, for example. So therefore, it is sufficient for your personal area network or very small network setup. Infra, okay, which is your remote control. Okay, so basically mainly is just one-to-one connection. Okay, as I mentioned, maybe your remote to control your TV is just one-to-one. Okay, one remote to one TV. Okay, so single device at a time. Key application will be remote control, point-to-point communication. Key feature limit to a single direct connection. Okay, so basically this is for low density wireless technology. Okay, let's move on to the medium density wireless technology. The number of connected device, okay, for just now, for the low density is 10 or maybe less than 10. So now they actually increase, okay, maybe up to 10 to maximum 100 device per access point, per gateway, etc. The key feature is basically they are suitable for small to medium scale deployment. They improve the resource management and scalability as compared to the low density technology. Okay, some of the example, okay, some of the older standard of Wi-Fi here. So the number of device that can connect to the so-called the router, probably maximum up to 50 device per access point at that time. Okay, the key application I think you know for Wi-Fi is basically to support our network coverage at home or maybe in small office here. So the key feature is basically we have limited device support with potential congestion as the network scale up. Okay, so basically we cannot afford to have more device connected to the gateway, for example, okay, because we potential may have some congestion issue. So basically this is only suitable for medium density wireless technology. The next one will be Bluetooth Low Energy. The maximum device that can hook up to a BLE is maybe maximum up to 50 connection. So the key application will be IoT device and also some fitness tracker. So the key feature is basically they have power efficiency communication, okay, for low bandwidth device. Okay, so basically this is what for medium device in terms of the number of connected device. Okay, let's move on to high density. Okay, you can see that the number of connected device increase, okay, even up to maximum 1,000 device per gateway, per access point or hub. Key feature, okay, you are going to have advanced resource allocation and device management. Okay, because the device and device increase, so therefore you must have a form of resource allocation for the device to so-called to access to the gateway, maybe at a unique time, maybe at a unique frequency, maybe at even different so-called resource here. So therefore, you need to have some form of advanced resource to manage this part here. So this one here, they are actually very suitable for environment, okay, with moderate to high device sensitivity. Some of the example, okay, for example, the newer Wi-Fi, or maybe these are the Wi-Fi that we are currently using before we onboard onto the Wi-Fi 7, the maximum device may be up to 200 device per access point. So some of the key application will be smart building, okay, in terms of campus and also some form of public hotspot here. Key feature is basically we can see how does this OFDMA actually and also this MUMIMO actually can improve the simultaneous connection, okay, under this Wi-Fi 6E. Next example for the high density wireless technology will be Zigbee. Okay, Zigbee in theory, the maximum device can be up to 65K device in a mesh network. Okay, keep this in mind, this is in theory. Okay, I think I have explained enough on the Zigbee in terms of the small smart home network and also the industry IoT. Key feature is basically for Zigbee, they are actually the first mesh topology that allow many devices to connect either direct or indirect through intermediate nodes here. So basically, this is for the high density wireless technology. The last one, okay, will be on the ultra high density wireless technology. Okay, so they can be even more than 1,000 device per gateway. So the key feature is basically they are designed for massive deployment with high concurrency, which means that they need to support multitasking, etc. So basically they are designed for massive deployment. Okay, basically they make use of new innovative spectrum sharing and resource allocation technique. Okay, so some of the example will be 5G. Okay, under this 5G, we have another special type, which is the massive machine type communication. Okay, so basically this is to support MBLT, for example, for this case here. Okay, so the number of devices that they can actually support will be maybe up to 1 million device per square kilometer. Okay, so basically this is still developing. I don't have much information on this at this point of time. Okay, but you can see that the number of devices that can hook up to the base station is 1 million device. Really amazing. Okay, so some of the key application will be smart city, autonomous vehicle, large scale IoT. Okay, so basically this is to support large amount of device. Okay, so because of this, they can support massive connection with low latency and also the energy efficiency. Okay, so the last one for ultra high density will be LoRa. Okay, recently LoRa gained quite a fair share of market share. Okay, so I believe that once MPLT become so-called mainstream, then LoRa market share will start to fall. But currently, you can see that LoRa market share start to pick up. Okay, so the maximum device will be thousands of device per gateway. Okay, so for LoRa, it is actually suitable for smart agriculture and for utility metering also. So for the key feature, they are actually optimized for wide area and also for low power IoT with large scale deployment potential. Okay, but we are going to anticipate large latency for LoRa form of communication here. Okay, so I put everything okay on the number of connected device on this table here. So you can see that this is low, medium, high, and ultra high density. You can see that the number of device that can hook up to the gateway also increase when you actually move from low, medium, high, and ultra high. And these are some of the example of the wireless connectivity that fall under the different category, okay, in terms of the density, some of the application, and also some of the feature which I have covered. Okay, with this, I'd like to end my discussion. Okay, please up to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you so much.